Hey, so to explain different types of polynomials, a monomial means I have one term, so 3, 4x, or even 5x squared y cubed z. I don't have a plus or minus attached, so each is one term. A binomial is 2, attached by either a plus or a minus. Trinomial is therefore 3, and a polynomial could be more than 3. With the examples, number 1, I have 2 terms, so it's a binomial. Number 2, I can combine like terms with 3x and 8x. Therefore, even though it starts out with 3, it itself is also a binomial. Number 3, I can combine like terms, so therefore that one becomes a trinomial. Number 4, even though I have multiple bases, they're all attached by multiplication, so it is a monomial. I hope that helps make sense. To explain the degree of a monomial, polynomial, binomial, any kind, we look at what is the highest power of each term. So in A, I have m to the first and n to the second, so that is a third degree polynomial. In B, my exponents for x, y, and z are 3, 1, and 6. That's a 10th degree term. In C, my a squared is a second degree polynomial. So to arrange in terms of the descending order, that means the largest exponent, which in this case is negative 2x to the third. Since 3 is the largest exponent, we'll go first, followed by my positive 6x squared, negative 8, x is now to the first power, and then a positive 5 because I do not have an x. Same thing in my second term. The largest exponent that I have is 5. So negative 2x to the fifth would be the first term. Negative 11x to the fourth, since it's descending by one exponent. I don't have a cube term, but I do have a positive 7x squared, last followed by my positive 8. And that's how we do descending powers. So when we add or subtract polynomials, we're looking at combining like terms. So my x terms combine to 3 minus 6, or negative 3. My y's combine to a positive 2. If we skip further down, I have a 3x squared plus a negative 7. Again, I want to keep it in descending powers. That's why we started with the squared. We now have a negative 4 and a positive 2x, and a positive 8 minus 5. Now it becomes complicated when you have a negative sign between them. So the largest sign I have is a cubed. My largest power is 13n cubed, minus 4n cubed, so 13 minus 4. Now I don't have any n squared, so I can bring that 3 down. And then I do have an n. 5n minus 7n is negative 2. This minus sign is the same thing as distributing by a negative 1. So I could have solved this by keeping my original as it was, and then negative 1 times 7 and negative 1 times 4, and then just combine like terms like before. Realize when you have perimeter questions, they're just combining like terms. So here's 4x minus 8, a 3, which is positive, and a negative 2x, and then an 11 with a positive y. Now that I've separated it, I can just add my like terms straight down. So I have a 2x, negative 8 and 3 makes negative 5 plus 11, and then last, I don't have anything to combine with y. And that would be my perimeter. Now when it comes to a missing side question, I like to look at what I currently have. So I currently have 2x squared minus 5, 3x squared plus 9x, And then I don't know the third side, but I know that this is the final perimeter. So if I add straight down the two sides that I currently know, this is what I have. Now I want to look at how does this change from the final perimeter answer, sorry I didn't mean to cross that out, to what I currently have when I add two sides. So the 5x squared doesn't change. From 9x to 7x, my third side should contain a -2. And to go from -5 to 12, I should add 17. So that is how to get my third side. It's like taking what I already know it equals and figuring out how would I go from the sum of two sides to the sum of three. So from 9 to 7 is take away 2. From -5 to 12 is add 17 more, which is how we find the third side. Now to find the perimeter of a rectangle when we're missing a width or a length, first I know that the perimeter, to add all four sides, I know that each of my lengths is 5x squared minus 3x, minus 3x plus 2. Now, similar to the triangle, I compare this answer, which is adding 2 of my four sides, and I say, well, from 10 to 14, I'm missing 4x squared. From -6 to 4, I would have to add to -6, 10, and then to go from 4 to -8, I'd have to take 12 away. Now that's equal to 2 of my widths. So to solve for the width, I would now divide all of this by 2, since that's what 2 of them make. So 4 divided by 2, 10 divided by 2, and -12 divided by 2 would equal my missing width. So when we distribute, we multiply the term on the outside by all of my terms inside. -4 times 2, -4 times -6, and then technically we want to write this in descending powers. So what we'd really want to do is we'd want to move the x term to the front. In our next problem, these are all different variables. So as far as descending powers, we could just keep in terms of alphabetical order. 3 times 5, 3 times 1q, and 3 times -3. When we look at a term like this, I can combine like terms and then triple it. That's one way to get it. Or we could have distributed 3 by 4 and 3 by 7. And then when we combine like terms, still found the answer to be 33x. Now for our laws of exponents, remember 3 times 7 is 21. But when I multiply 2 x's by 3 x's, we add the exponents, so we actually have 5 x's. 8 times 1, and then I have 5 m's times 1m. Add 5 and 1 to get 6. When we get to a more complicated problem, this is to the first power, so I can multiply 3 times 2, which is 6, times 7, 5 r's, 2 r's, and 6. Well, 5 plus 2 is 7, plus 6 is 13. So to distribute 4 times 2, 1x and 1x makes 2x's, or x squared. 4 times 6 makes 24. So 8x squared plus 24x. 9 times 5, 2 y's and 1 y makes 3. 9 times -3, and I just bring along the y squared. So when the problems get really hard, 2 times 3, 1p and 2p's makes 3, and I just bring along my q. 2 times 6 is 12. 1p and 1p makes 2. 1q and 1q makes 2. 2 times 7. 1p times no p's, well, 1 and 0 makes 1. And 1q and 2 makes 3. Now, some teachers like to teach this as far as what we call a box method. So here's my monomial, 6y squared. And then here's my trinomial of 4y squared minus 9y minus 7. So in my first box, 6 times 4 is 24. 2y's and 2y's makes 4. 6 times negative 9. 2y's and 1y makes 3. 6 times negative 7. No y's plus 2y's makes 2. All of these are different terms, or I should say different variables, to a different power. So I cannot combine anything since these are all different terms. I just simply bring it outside the rectangle, and there is my final answer. To find the area when we have a shaded figure, and try to find the area whether it's of the shaded or unshaded. In this case, we're asked to find the shaded region. The formula is find the big shape area minus the little shape area. So the area of our square is our big shape. Well, the side length is 8. So the area of the square minus the area of the triangle, and side squared, or 8 squared, which is 64, minus the area of the triangle. Well, base times height divided by 2. 1/2, 4 times 3. Half of 4 is 2, times 3 is 6, making the shaded region area 64 minus 6, or 58.